Hello friends, welcome to the Gujarat Technological University Active Learning Video Communication Series. I am Sanketsingh Thakor, lecturer of physics, Gandhinagar Institute of Technology, Gandhinagar. First of all, I am very thankful to Gujarat Technological University, all my viewers and coordinator of the Active Learning Video Communication Series to give me a chance to be a part of this entire Active Learning Video Communication Series. Friends, today we are going to concentrate on the frequently asked question in GTU examination of physics subject from 2009 to 2012. And the first question, discuss the various factors affecting the acoustic of buildings and give their remedies. In the bracket you can see the marks of this question. Friends, here I want to mention one thing. This question was asked in 7 marks as well as 4 marks. So if this question will asked in 4 marks, then you have to mention just 4 factor affecting on acoustic of buildings. And if this question is asked in 7 marks, then you have to write all 7 factor affecting acoustic of building. You have to start with various factor affecting on acoustic of building are explained in brief this section. The first factor which is affecting on acoustic of building is the reverberation time. Friends, you know that the reverberation time is related with the reverberation effect. Please friend, reverberation time or reverberation effect is not an echo effect. There is a big difference between the echo and reverberation effect. So in reverberation effect, you have to start with, it is the persistence of a sound in a hall even after the source stopped emitting sound, or you can say it is a prolongation of sound in a hall even after the source of sound is cut off. Friends, in order to have a good acoustic effect, the reverberation time has to be maintained at the optimum value. It should not be maximum, it should not be minimum. It has to be maintained at the optimum value. Remedies of this factor, you can see the 3 remedies of this factor. First is by providing window and openings. Second, the using curtains with the folds, and by covering the floor with the carpets. The second factor which is affecting on acoustic of building is loudness. Friends, you know that loudness is a characteristics of musical sound and it contains a WEBER FECHNER law. The uniform distributions of the loudness in a hall is an important factor for the satisfactory hearing. It may get reduced due to the excess of the sound absorbing material used inside the hall or a room. Remedies of this factor is, if loudness is inadequate, it can be increased by adopting the following method. By using the suitable absorption at the place where noise is high, by constructing a low ceiling for the reflection of the sound toward the listener. Third factor which is affecting on the acoustic of building is focusing and interference effect. The presence of any concave surface in the hall may make the sound to be concentrated at that region. So sound may not be heard at the all other region, and that specific region is called death region. Addition to the focusing effect, there should not be interference of the direct and reflected wave. If there is an interference of the direct and reflected wave is there, then there will be a probability of a constructive interference as well as a destructive interference. and resultant there will be a produce minimum intensity of sound at the other place. So resultant uneven distributions of an intensity, and remedy of this factor is curved surface may be avoided in the hall or in the room. Next factor which is affecting on the acoustic of building is resonance. If the window panels and the sections of a wooden portion have not been tightly fitted, they may start vibrating, and due to the matching of the frequency, resonance may occur. You know that if the natural frequency and the frequency of the windows panels will be equal, then there will be a probability of a resonance, and it will be a factor which is affecting on the acoustic of building. Remedy of this resonance factor: by fixing the window panels properly, the resonance may be avoided. The fifth factor which is affecting on acoustic of building is echo or echolant effect. Here I want to mention that the reverberation effect and echolant effect is a different thing. Echo is heard due to the reflection of a sound from a distant sound reflecting object. An echolant effect refers to generation of a new separate sound due to the multiple echo, and remedies of this effect that can be avoided by the covering long distance wall and high ceiling with the sound absorbing material. Last factor which is affecting on acoustic building is noise. There are three types of noise: airborne noise, structure noise, and inside noise. Airborne noise, which are coming from the open windows, doors, and ventilators. Structure noise, which is conveyed to the structure of the building, and inside noise, which are produced inside a hall due to the machineries like air conditioners, refrigerators, or fan, or etc. Remedies of this factor: for inside noise can be avoided by using curtains of a sound absorbing material. For structure borne noise, it can be avoided by using double walls with the air space between them. Airborne noise can be avoided by using doors and window with the separate frames with the proper sound absorbing material. Next question: state and explain Weber Fechner law. My friends, this question is also belong to architectural acoustics unit. This is a very short question. This is related to loudness characteristics. Loudness is the second characteristics of a musical sound. First of all, you have to write a definition of a loudness. Loudness is directly proportional to the logarithm of an intensity and is known as Weber Fechner law. Then the definition of loudness is it is a degree of sensation produced on ear, and the depend upon the intensity and also upon the sensitiveness of the human ear. Loudness and intensity are related to each other by the relation L is equal to K log I, where K is the constant, and from this equation we can write dl upon dl is equal to K by I. dl upon dl is called the sensitiveness of the human ear, which is decreases with the increases in the intensity. Next question: explain the principal construction and working of a magnetostriction effect or a pizoelectric effect of a method of producing ultrasonic wave. My friends, I just combine a magnetostriction effect and piezoelectric effect in this question. You can see the previous examination paper. You will get a one of this definitely. So first of all, we are going with the magnetostriction effect. When this question is asked in 7 marks, then you have to write specific manner. First, you have to start with principle. So the principle of a magnetostriction effect is when the rod of ferromagnetic materials such as iron or a nickel is kept in a magnetic field parallel to its length, the rod suffers a change in a length as shown in figure. The change in the length is independent of the direction of the magnetic field and depend on only the magnitude of the field and the nature of the material. This whole phenomenon is called magnetostriction effect. Due to the resonance, the rod is thrown into the longitudinal vibration, producing ultrasonic wave in surrounding medium. Such a ferromagnetic materials which are used for the production of an ultrasonic waves are called magnetostriction materials. Basically, when the ferromagnetic materials, or you can say a ferromagnetic materials rod's frequency will become equal to the natural frequency, then there will be a production of an ultrasonic wave. Here you can see the circuit diagram or construction of a magnetostriction effect. As shown in figure, the ferromagnetic rod XY is clamped in the middle. The coil L1 and L2 wound at the end of the rod. To the coil L1, a variable capacitor C1 is connected into the parallel, and this combination forms a tank or a resonance circuit. One side of the resonance circuit is connected to the collector of the transistor through a millimeter. The other side of the resonance circuit is connected to the emitter through the battery. The coil L2 is connected between the base and emitter. This whole is the constructions of a magnetostriction effect as shown in. When the battery is switched on, the resonance circuit L1C1, which is also called a tank circuit, in the collector circuit of the transistor set up an alternating current of m frequency, and the frequency of that current will be given by f is equal to 1 upon 2 pi under root L1 C1. As a result, the rod get magnetized by the collector currents. Any change in the collector current brings about the change in the magnetizations and consequently a change in the length of the rod. This gives rise a change in a flux in a coil L2 in the base circuit, thereby inducing an EMF in the coil L2. This varying EMF is applied to the base of the transistor and is fed back to the coil L1, thereby maintaining an oscillation. By varying the capacitor C1, the frequency of oscillation of the tank circuit get varied. If the frequency of the tank circuit matches with the natural frequency of the materials, then due to the resonance, the rod will vibrate, producing ultrasonic wave. The millimeter reading gives the maximum value at the resonance condition. The frequency of an ultrasonic wave was produced by this. Method depend on the length of the rod, density of the materials, and the elastic constants capital E. And the equations can be written by F is equal to 1 upon 2L under root capital E upon rho. So finally, thus by varying L, length of the rod, and E of the rod, ultrasonic wave can be generated at the desired frequency. Before we see the merits, the conclusion of the whole theory is you have to give AC frequency to the ultrasonic ferromagnetic rod. Due to the change in the frequency of the L1 rod, there will be a change into the flux of the L2. That change in the flux into the L2 will feed back to the circuit by the base of a transistor. When the frequency of the externally applied oscillator will be equal to the natural frequency of the ferromagnetic rod, there will be a production of ultrasonic wave at the end of the rod. Merit, or you can say application. The design of this oscillator is very simple and production is very low cost. At a low ultrasonic frequency, large power output is possible without risk of damage, and the frequency range which can be generated by this method is 1000 Hz to 300 Hz to 3000 Hz. Demerit, or you can say disadvantage. It cannot generate the ultrasonic wave frequency above the 3000 kHz. The frequency of oscillations depend greatly on the temperature. There will be a losses of energy due to the hysteresis and eddy currents. Second, a piezoelectric method. The piezoelectric method of producing of ultrasonic wave is based on the principle of inverse piezoelectric effect. This is the principle of inverse piezoelectric effect. If the alternating voltage is applied to the one pair of an opposite face of the crystal, alternatively, mechanically, contraction and expansion are produced in the crystals and the crystals start vibrating. Same as into the magnetostriction effect, when the frequency of an oscillator will become equal to the frequency of the vibration of these particularly piezoelectric crystals, then there will be a production of an ultrasonic wave. Here you can see the circuit diagram